So I'll be teaching you about the linear form of differential equation. So a differential equation in the form of dy by dx plus py equals to q is in the linear form where p and q are functions of x or constants only. So this is called the linear form because if you plot the differential equation in a graph, you get a straight line. So, and here the unique thing about linear form is that you have an integrating factor, and the integrating factor is e to the power of the integration of p dx. Yes, this is the integrating factor. So what is the integrating factor? Well, the integrating factor is when you obtain this result, you can multiply the integrating factor to this equation and it will make it simple for you to solve that equation. So I'll show you what I mean. Let's try the first question of exercise 15.5, basic mathematics. So here, this is a linear form because of dy by dx plus 3y equals to e to the power minus x. Here p is 3, which is a constant, and e to the power minus x, which is the function of x. So here, the integrating factor, if or mu x, is equals to e to the integration of p, which is 3 dx. So the integration of a constant is just that constant into x, which is e to the power 3x. Now what we do is multiply both sides with respect with the integrating factor. So what we get is e to the power 3x into dy by dx plus 3y equals to e to the power minus x. So what we'll have is e to the power 3x dy by dx plus 3 e to the power 3x y is equals to, well, you can just add the power 3x minus x, which is e to the power 2x. Now for this part we have to use the exact form or the concept in exact form, in which we have to find the derivative of all of this. Now we have e to the power 3x dy by dx. So like I said in the previous video, it's always good to check the derivative of the function of x, y. So for here we have the derivative of e to the power 3xy. Let's check that. So we'll get e to the power 3x dy by dx plus y into the derivative of e to the power 3x, which is 3 into e to the power 3x dx by dx, which is 1, and which is equals to this. And here this whole thing matches that. So in fact we will have the derivative of e to the power 3x into y, which will equal to e to the power 2x. Now we can integrate both sides. This will be respect to dx. Because here you can just multiply both sides with dx. So you'll get dx over here, and you'll get the same thing. So this cancels, you get e to the power 3x into y, which is equals to e to the power 2x by 2 plus c. Now this is the answer. Let's try another question. Here this is also in the linear form, but here, well, we have to get rid of the x first because we need dy by dx only. So we'll divide everything by x. So we have dy by dx minus y by x is equals to 2x squared. Now here, if you compare it with dy by dx plus py equals to q, p here is minus 1 by x and q is 2x squared. So the integrating factor is equals to e to the power minus 1 by x dx, which is equals to e to the power, I'll write it below, e to the power minus ln x, and we can put the minus inside, so we'll get e to the power ln x to the power minus 1. And here you can use a log property which is not that common, but this e and this log will cancel, so you'll get e to x to the power minus 1. So you have to multiply this on both sides. So let's do it directly. We will have 1 by x, because this is 1 by x, into dy by dx minus y by x squared is equals to 2x. Oof, this is tricky, but basically in linear form, after using the integrating factor, you in most of the questions you have to use the concept of exact form, which is to find the derivative of this. Now, as I said earlier, if you have 1 by x dy by dx, it's always good to check the function of this with y. So let's check it right over here. Let's check the derivative of the function y by x. So for y by x, or let's just do it like this, 1 by x into y, so you don't get confused with the quotient rule. So first of all, we will get 1 by x dy by dx plus y into the derivative of 1 by x. So we need the derivative of 1 by x. So here this is just x to the power minus 1, and the power comes first, power minus 1, which is equals to minus 1 by x squared. So this into minus 1 by x squared, and dx by dx is just 1. So we'll get 1 by x dy by dx, this minus comes forward, minus y by x squared. So this matches with that. So what we know is that this is the derivative of 1 by x into y, which we can write it as y by x, which is equals to 2x. Now simply we can integrate both sides. This cancels, this is with respect to dx. Y by x equals to, well, the derivative of x squared is 2x. I think that's the most famous derivative besides e to the power x and ln x. The 2 just comes forward. So here this is just x squared plus c, therefore y equals to x cubed plus cx. X cubed plus cx. Now let's do another question. Now we know what to do. Let's find the integrating factor, which is e to the power, well here p, wait, one thing, we have to just make it dy by dx. So we have to divide everything by 10x. So we'll have dy by dx plus, well, 1 by 10x is just cot x y equals to sec x is 1 by cos x into cos x by sin x, because cot x, this cancels, 1 by sin x, which just gives us cosec x.